come and watch it. Thank you. So now, at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we'll be sharing today. Without further ado, I will pass it on to our presenters, and I will also post the link so that you can move to the 1324 room.
Okay, guys. Good afternoon. I'm gonna be subbing in for Miss Shuka. She's running a little bit late. Let's just give them a couple minutes for those who are gonna leave to the 1324 room, and let's give them a couple minutes and 1 minute, and then I will go ahead and start the 1314 session in this room. Let's just give them a couple of minutes to everyone to settle down. Okay, I think that's everyone's pretty set now. Like I was mentioning, Meshuka's running a little bit late, so I'm gonna sub in until she comes in. We're gonna be talking about exponential logarithms and their equations and properties, and we're just gonna start off with the problem like this. We have log base 5 of 125 equals x. We're gonna try solving for x. So what we're gonna do here, we're gonna do the change of exponential equation. So notice how we have log base 5 of 125 equal to x. We're trying to figure out what x is equal to, or what x is our value. So what we're trying to do, we're going to go from logarithm form to exponential form. See, the good thing about logs, or what logs are actually good used for, if I were to give you a problem and tell you what's 10 to the power of 1, well, you can easily tell me that's 10, right? 10 to the power of 1. Now, if I tell you, well, what's 10 to the power of 2, you can also tell me 10 times 10, that's 100. But now, if I tell you 10 to the power of what gives me 50, now we start running into a little mind trick, right? Well, 10 to the 1/2, no, not really, it doesn't work like that. So that's when we have to go back to using logs functions, logarithm functions. That will become log of 10 of 50 equals x. So we can use, and by the way, I should have done this arrow both ways because it can go back and forth. Not only is it, we can go from log function to, sorry, from exponential function to log function, we can also go from log function to exponential function, which is exactly what we did here in this problem. We had log base 5 of 125. This right here became my base. Is going to become my base, where the whatever is on the equation side is going to become my exponent, and whatever was here on the inside the logarithm, that's what it's going to be equal to. As you can tell here, 10 base x of 50, the 10 became the base of the logarithm, the 50 went inside the logarithm, and the x, my exponent, that's what I'm trying to figure out. Again, you can go back and forth between exponential and logarithm. So with that being said, we get here that we got 5x to the 125. Now, where did the 5 cube came from? Well, we're doing a little bit trick here, because we know that 125 can also be rewritten as 5 times 5 times 5. Why do we want to put it in this form? Why do we care that it's 5 times 5 times 5? Well, if we know that it's 5 to the x, and we know that it's 5 cubed, because they have the same base, we kind of just, it's not cheating or anything, but we can just do a little trick and cancel those two right there. It's called having the same base. In other words, I'm left with x equals 3. Again, so let me go a little bit over this. So the first thing we did, we changed it into exponential. And then from there, we moved it to we put it the same base. And from once it was with the same base, we were able to just cancel the bases, and we're left with x equals 3. Did that make sense to everyone? Did everyone see how that happened, or is there any questions on this particular problem? Okay. With that being said, I see that Meshuka came in, so let me see if she's ready to take over. Give us a quick minute here.
Hello, everyone. I apologize. I was trying to get out of traffic, but I'm here now. Thank you, Jesus, for covering the first few slides. And so we'll just continue. Okay, so let's go ahead and continue here. let's see. So we want to solve for x for this. So in order to solve for x, one of the ways we can do this is to change it to exponential form. And so if we do that, you want to take the base. So here we have our base is 2. So we get 2 to the x is equal to 25. But notice here that unlike the other question that we had, 25, we cannot write it so that it has a base 2. So a calculator will be handy in this situation. And so on the next slide, I have 2 pictures of 2 calculators. One is a Casio, and in this Casio, they actually let you put the base in here. But in a regular TI-83, they don't let you put the base. So the log that we see here is base 10. And so we need something that will help us. Yes, you can get a calculator like the one on the right side, but you don't need it. If you have the one on the left side or something that doesn't have that function, then we use something called the change of base. And the change of base tells us that if you have a log that is something other than 10 or e, then we can rewrite it as log b x and log b of a, where the b, we just make it a base of 10 so that we can use our calculator, or you can make it the natural log with the base e, and then that you can also use on your calculator. So the next examples is going to talk about the change of base. So here it says to evaluate using the change of base. So we'll look at the first one first. So here, since we have log 311, if your calculator doesn't allow you to input it this way, then we would have to rewrite it using the change of base. So the way we do that is we take the log of 11 divided by the log of the base, in this case 3. When you enter it in your calculator, notice I have parentheses around my numbers. So I have log 11 divided by log 3, and then I get this answer here. And it does say to round to 3 decimals. So I'm going to look at the 6 here, and it's going to become a 3. So my answer here is 2.183. Okay, so let's look at the next one. So for B, same thing here. So we would have log of 0.5 would be our numerator, and then the base would be in the denominator. Log of pi would be in the denominator. And notice that I'm not using equal signs here because it's not an exact answer, it's an approximation. And so if we put this in the calculator, then we end up with negative 0.606. So we want to make sure that we're rounding to 3 decimal places. So last time that we were here, we went over the properties that are down here. And today we'll look at 3 more. So we have the product property that says if you have a log and you're multiplying 2 expressions inside, we can separate with addition. And the quotient property tells us that if we're dividing a log of 2 expressions, we can separate with subtraction. And then the power property tells us that this exponent we could bring to the front of the log, and then you have the same properties for the natural log. And so the power property is one that you can use quite a bit in the 3.4 section. And so these are very basic ones, and then we'll get into some more difficult ones here. So it says use the properties of log, and all these questions that we're looking at, I took them straight from WebAssign. So all of these are coming from WebAssign. These are properties of logarithms to write the logarithm in terms of log 5.2 and log 5.3. So this is the problem here, log 5.6. So you want to think about 6. What numbers can we use to multiply and get 6? They kind of give you a hint here because they have the 2 and the 3. So if we rewrite 6, we're going to use the product rule, and we can write 6 as 2 times 3. And so since the product rule tells me that I can separate these as addition, then I would be left with log 5.2 plus log 5.3. Okay, so let's go to the next one. Find the exact value. So here they want you to find the exact value. Let me just go back. Okay. So we have log 4 of the cube root of 4. So in order to do this, we want to look at these roots and we want to rewrite them as a power. And so anytime you have any type of root, so for example, if you had, let me get the pen out, the square root of x, this is the same as x to the half power. If you have the cube root, then you just have your exponent would be a fraction of with the index. So this would be x to the 1/4 and so on. And so let me just erase this. Oops. So they actually made it so that you can erase certain parts only. So that's good. So let's rewrite it. So instead of log 4 cube root of 4, we have log 4 raised to the 1/3 power. And then we're going to apply the power rule, which means that we're going to take this exponent here and we're going to move it to the front of the log. And so I have 1/3 log 4 to 4. And then we can use the properties that we had last time. So if you notice, if you have a log of 4 with this number here being the same as the base, then we can use property number 2. So it says that log a of a is going to be equal to 1. And so I can replace log 4 of 4 with 1. And so 1/3 times 1 is going to be 1/3. So your answer to this would be the 1/3. That's what you would put in your computer. Please let me know if you have any questions. I can stop and answer those. Okay. So find the exact value without using a calculator. So this is similar to the other one. Anytime you see this this root here, I always think about maybe if I change it to exponential form, to exponent, then it might be easy for me to solve. Okay, so here we're going to rewrite the 4th root as an exponent. So I have natural log of e cubed of 1/4. And then we're going to use the power rule, or we can simplify first. So e cubed raised to the 1/4. The properties of exponents will tell us to multiply. So we get e to the 3/4. And now we can use the power rule. So we're going to take the 3/4 to the front. And so we have 3/4 natural log of v. And just remember from last time, natural log of v is the same as log of base e of e. And so since these are the same, this whole thing would be equal to 1. So anytime you see natural log and e, that is just going to be 1. So this right here is always 1. And the reason being that we can use property number 2 because they have the same base here. And so if we replace it with the 1, then our answer would be 3/4. Okay, so let's look at letter B. Here we have natural log of e4 plus natural log of e8. And so we can apply the power rule. We want to take these exponents to the front. And so the 4 is going to come to the front, and then the 8 is going to come to the front. We know that natural log of e is going to be equal to what? To 1. Okay, so we can use the same property, property number 2. So we get 4 times 1 plus 8 times 1. And 4 plus 8 is going to be 12. Any questions on that one? Okay, it says use the properties of logarithms to expand. So expand means that, well, expand, you guys know what expand means, but you'll see here, expand in the terms of logarithms is to rewrite this logarithm as a sum or a difference or multiple logarithms. So instead of having one logarithm here, your answer is going to have multiple ones. Okay, so first we're going to apply the product rule. So notice that you're multiplying z times z minus 1 to the 4th power. So since they're being multiplied, we can separate them with addition. So I'm going to have natural log of z plus, and I forgot, this should have a natural log in here. So let me just add it. Get the color here. I forgot my natural log there. So that should have a natural log. And then we're going to apply the power rule. Okay. So now you can see that I added it here. So the power rule tells me to bring the 4 to the front of the natural log. Oops, let me go back. And so now you can see that from 1 natural log, now we have 2 natural logs. But we were able to separate using the product rule. Since these were being multiplied, then we went ahead and added them. I have an exponent, I can bring it to the front. Now we're gonna do the same for this. And for my students, this question was, I had several questions on this one. And so hopefully this will help you out, even if you're not in my class. And so we want to again expand it. So that means your answer should have more than 1 log. And so we want to observe what's going on here. We have 2 expressions are being divided. So we're going to apply the quotient rule, which says we can separate them with subtraction. Okay, so I'm going to have log 5 of the numerator, x squared minus 9, minus log 5 of the denominator, 4. So now let's work with the left side. Since you have a square root, you can change the square root to an exponent. So we're going to rewrite it. So instead of square root, I'm going to have a power of a half. And then what property can I use to make this half go to the front? What is that called? And so that one's called the power rule, right? So we're going to take the power rule and we're going to take the half to the front. And then some students might want to leave the answer like this, but you want to observe everything. So like in the parentheses, you have x squared minus 9. We can factor that. That's going to come out as 1/2 log 5 x minus 3 times x plus 3. So now if you notice, these two are being multiplied, and so I can separate them with addition or subtraction. So if it's multiplication, we can separate with addition. So we apply the product rule. So now we're going to take this half, and the half is going to need to be applied to all of that logarithm. So we're going to have 1/2 log 5 of x minus 3. Since they were being multiplied, I can add 1/2 log 5 of x plus 3. Again, this half in the front belongs to the entire log, so we need to apply it to both parts. And then you have your log 5 of 4. Okay, any questions on that? So the power rule is going to be used quite a bit. Okay, so let's look at this one here. User properties, again, same thing, right? So notice that they're being divided, so we can apply the quotient rule. So division is going to separate as subtraction. So I get log 8x cubed minus log 8y cubed times 0 to the 4. So now what is happening here? These are being multiplied, so you can separate these by using the product rule. So now we're going to have log 8x cubed minus log 8y cubed plus log 8z to the 4. Notice I put parentheses. I put parentheses because the subtraction applies to the entire log here. So I want to make sure that this subtraction applies to everything I get after that subtraction. And so now we can distribute that negative. And so we're going to get log x cubed minus log 8y cubed and then minus log 8z to the 4th. And am I done here, or is there any other rule that I could use to simplify further? We can use a power rule, right? So I'm going to apply the power rule. So the 3 is going to come to the front, and then this 3 is going to come to the front, and the 4 is going to come to the front. So my answer will look like this. Let me go back. Click too fast. Okay. All right, so let's try this one here. So what would you want to do first here? All of this is being trapped by what? That root, right? So we're going to rewrite the root. Instead of the square root of 10, we're going to change it to an exponent. And so we end up with natural log of everything that was inside raised to the power of 1 over 10. Okay. So now all of this in here is kind of trapped together by this exponent. So let's get rid of this exponent first by using the power rule, and we can move it to the front. So by doing that, these are kind of free now. And notice here you're multiplying x to the 7 times this parentheses. Since we're multiplying, we can apply the product rule, which says that if you multiply, we're going to separate with addition. So we get 1/10 of natural log x to the 7th plus natural log of x to the 5th plus 7. So now in here, we have to be careful. We cannot separate these. These are together. So the only thing left for us to do is to distribute that 1/10. So 1/10 into natural log x times 7, and then 1/10 in times natural log of x to the 5th plus 7. So this was going to be your answer here. Okay. And that I just entered extra information, but so here in red is your final answer, right? We need to apply the power rule. So the 7 is going to come to the front. So 7 times 1 is 7/10. And then we have this 1/10 remains the same. And so this is your final answer. So why is all this even important? Like, why are we doing this? Really, the main purpose is to be able to solve an equation, and you'll see that in a little bit. Okay, so earlier we were expanding, now we're condensing. Okay, so condensing means instead of having multiple logarithms, we want to have just one logarithm. So you want to find a way to combine these logarithms. So the first thing you want to do is ask yourself, do I have any numbers in front of the logs? And if you do, you want to take care of those numbers first. So if it's in front of a log, that means that it came from where? From an exponent, right? And so always take care of those first. Okay, so in this case, this one doesn't have a number. Well, it's a 1, but it's okay. Here, this 9, we need to take care of the 9. So we're going to change the 9. We're going to move it back to the exponent. So it's kind of like you're working backwards. Okay, so everybody see that the 9 came back to the exponent. And now you want to ask yourself, okay, what is happening with these logarithms? They're being subtracted. So that means that I'm either going to multiply or divide. So subtraction means that we're going to be dividing. So we're applying the quotient rule backwards, right? So we're going to take the log 6 of 3x divided by x to the 9. Okay. So we can simplify. So actually, if you enter this answer on WebAssign, it's going to count it correct for you. But always try to simplify. And so here I have 1x on top, and then I have x to the 9th. And so if I simplify here, this x will cancel with one of these, giving me x to the 8. So if you enter this answer, it's going to be correct. If you enter this one, WebAssign is going to count it correct. So either answer would be fine. Okay, so here again, condense, right? Put back together. Notice this example has no parentheses, and this example has parentheses. If you don't have parentheses, then just start from left to right. If you have parentheses, then you want to work within the parentheses first. So here, I'm going to go ahead and I'm going to focus on these first two. So what is the first thing I should do though? What was that first thing I mentioned earlier? want to take care of any number that is in the front of the logs, right? So let's go ahead and do that. So I have log x, the 6 comes back to an exponent, and the 7 goes back to being an exponent. And so now let's work on these two. Oh, I can't get this. I'm trying to write, but it's not letting me write. Okay. So let's work on log x minus log y to the 6. Since you're subtracting, we're going to combine it using the quotient rule, and we're going to divide them. So we have log x divided by y to the 6. Then we have plus log z of 7. Now we're adding, so we're going to combine using the product rule, which tells us that we're going to do what? Multiply. So we get x divided by y to the 6 times z to the 7th. And so if we simplify, then x times z to the 7 is going to be x times z to the 7th divided by y6. So this is what I would enter in my answer box. Okay, so again, the point, one of the things you want to remember is if you don't have a parentheses, then just start from left to right. And this other letter B, we do have a parentheses. So we want to start with this here. So these are being added. So we can combine them by using multiplication. So we have x plus 1 times x minus 1. So I can simplify in here. So I get natural log of x squared minus x plus x minus 1. The x's will become 0, so I get x squared minus 1. And now I have subtraction. So subtraction means to get one log by dividing. So we apply the quotient rule, natural log of x divided by x squared minus 1. Any questions on that one? Okay, so you'll start to see right now why we want to do this, okay? We're trying to solve equations, we're trying to solve the variables. So these three examples are examples that you have seen in the past sessions. The first one, and there are several ways to solve these, but one of the ways would be to make this 4 have the same base. And so we would get 2 squared, and then we can use the 1-to-1 property. So this answer would be x is equal to 2. Okay, let's look at letter B. So now you can try to use the properties here. Natural log of x minus natural log of 13. Since I have an x here, it makes it a little bit more difficult. So one of the things that I can use is the properties. Since I'm subtracting, then I can combine them. Well, there's two ways, right? You can combine them into one logarithm, or if you take the natural log of 13 and add it to both sides, then we get natural log of x equals natural log of 13. In my opinion, trying to make this so that they have the same base and then apply the 1-to-1 property makes it a lot easier or a lot faster. So since they have the same base, I can say that x is equal to 13. But like I mentioned earlier, there's other ways to solve these. Okay, let's look at letter C. Here we have e to the x is equal to 13. What I'm about to do in this example is something that you're going to use quite a bit, okay? So in order to get rid of this, if I multiply by natural log on both sides, and you can multiply by anything as long as you do it on both sides. So natural log of e to the x times natural log of 13. Then earlier in these examples, we said that natural log of e becomes a 1, right? So I get, so natural log of e, let me just see if this thing lets me write. So remember, this kind of becomes, people say that they cancel. I don't like to say they cancel, but because of the properties, it becomes a 1. But if you feel like drawing a line through it helps you, then that's fine. So this is 1 raised to the x. We're going to have x and then natural log of 13. So we can use the calculator, natural log of 13, and then round to 3 decimal places. Okay. So here's a 9, so I'm going to make that 4 or 5. So that idea, you're going to use it quite a bit. So let's look at this one. We have e to the x is equal to e x squared minus 6. Well, notice that they both have the same base e, so we can apply the 1-to-1 property. So we're going to get x equals x squared minus 6. This is a quadratic equation. So in order to solve a quadratic equation, everything has to be on the same side. So I'm going to subtract x on both sides. And then you have choices. You can factor or use the quadratic formula. Well, maybe I shouldn't say that because not everything factors, but one of the 2 methods will work here. In this case, it does factor. So x minus 3 times x plus 2. And then I can set each factor equal to 0 and solve for x. So x equals 3, x equals negative 2. Okay. So again, I'm highlighting the 1-to-1 property. So here it says solve the exponential equation algebraically, and then round to 2 decimals. The first thing you want to do when you're trying to do these problems is to isolate the exponential part. And the exponential part is the number that has that variable x. And so in this case, in order to isolate 3 to the x, I have to get rid of this 5. So to get rid of the 5, I'm going to divide by 5 on both sides. So 5 divided by 5 is going to give me a 1, right? So here, divide by 5. So the 5's become 1. So what 20 divided by 5 is 4. Okay, so we get 3 to the x is equal to 4. And now we are left with 3 to the x equal to 4. Well, there's no way for me to make 4 to have a base of 3. So when we're stuck here, then we can multiply natural log on both sides. So this idea is going to be very helpful, and you can use this quite a bit. So multiply natural log here and natural log here. And what is it that we're trying to do? We're trying to solve for x. Okay, so if x was down here, we would be able to solve it. So we're going to apply the power rule so that we can bring the x down. Okay, so we're going to bring that x to the front. And so now I have x natural log of 3 is equal to natural log of 4. And how do I solve for x here? I'm going to divide by natural log of 3. Okay, so now I have this answer. And so we can evaluate it. Notice how I enter it in my calculator. Natural log of 4 divided by natural log of 3. And we end up with 1.262. So if you have a smaller calculator where it doesn't let you do this and you have to do natural log of 4 first and then write the decimals, whatever you do, just don't round to the very end. Okay, so here I need to isolate the exponential part. So this e to the has to stay by itself. So I need to get rid of negative 9 here. And I can do that by adding 9 on both sides. Okay, so I get e to the x is equal to, and this is going to be wrong right now, but I do change it. You'll see that I change it here. I think I didn't change it till the very end. So let me just go really quick. So 9 plus 36 is 45, right? And then in order to get rid of this, bring the x to the front, I'm going to multiply by natural log on both sides. And then I can use the power rule. So the x comes to the front. They're actually natural log and e become a 1, right? So if you bring the x to the front, then natural log of e times is 1. 1 times x is x. And then we have natural log of 45. So x is approximately 3.807. Okay. So again, anytime that you're trying to get this x to be come down so that it's not an exponent, we can multiply by natural log on both sides, and then we can use the par rule to bring the x to the front. And natural log of e is just 1, so 1 times x is x. Okay, solve this logarithmic equation. So now you want to solve for x, but x is kind of like trapped with that logarithm. So somehow we need to make it so that x is not trapped in there. So let's go ahead and, oops, I kind of skipped really quick. Okay, well, so natural log, the first thing you want to do is, since you're starting with a natural log, maybe if you're not sure where to begin, then you can tell yourself, what if I change it to exponential form? Maybe that would be easier. And so that's what I do in this case. Natural log is the same as log of base e of x is equal to -4. So if I change this to an exponential function, my base is e. This whole log is always equal to the exponent. So that becomes e to the -4. And then that's going to be equal to x. So e to the -4, I plug it in the calculator, and so I end up with 0.018. So again, natural log is the same as log with base e, and then change this right here into exponential form. The base is e, and the way I remember is that the log is equal to the exponent. That means that -4 is going to be my exponent. Okay, so we're going to do a couple of more of these. Okay, so here we have 2.8 equals natural log of 3x. Well, the x is trapped with the natural log of 3x. If I forgot my parentheses there. So in order to get rid of this, maybe we change it to exponential function or an exponential form. We're going to have the natural log is the same as log with the base e. Okay, so ln is the same as log e. So my base here is e. Again, the log is equal to the exponent. So here's my log, and it's equal to 2.8. So that's going to be your exponent is equal to 3x. We're trying to solve for x. So we can divide by 3 on both sides, and we get x is equal to this right here. If you enter this in WebAssign, it's going to count it wrong. You want to simplify it since they're asking for a decimal, right? So the way I enter it on the calculator, e raised to the power of 2.8 divided by 3. You don't have to do it together. You could have pressed e to the 28 and then enter and then divide by 3, as long as you're not rounding until the very end. So I have a 5 here, round to makes it a 2. Is there any questions on this one here? Excuse me. Okay, let's check the next one. Again, you're trying to solve for x, so we need to isolate the natural log here with the x. So I need to get rid of this 5. I'm going to subtract 5 on both sides. So now I'm left with -5 natural log of x is equal to 11 minus 5. Simplified, so 11 minus 5 is 6. And I still have this -5 that I need to get rid of. So I can divide by -5 on both sides. And so I'm left with natural log of x is equal to -6 divided by 5. Okay, so now to work with this, we can change it to exponential form. So natural log is the same as log e of x. So my base is e, and again, this log is equal to the exponent, so that makes this the exponent is equal to x. Put it in your calculator, and so we get approximately 0.301. Okay. And so now they keep getting a little bit, we keep adding more and more logarithms in there, right? So It says solve the logarithmic equation. The logarithmic equation algebraically. So natural log of x minus natural log of x plus 6 is equal to 7. Okay. So if you notice in these problems over here, we always only had one natural log. Okay. Or if we had two natural logs, it was the same base. And so one of your goals can be, well, I have two natural logs here. How can I make it so that I only have one natural log? And so if these are being subtracted, am I going to combine them by dividing or multiplying? Am I going to condense them by dividing or by multiplying? Divide. So subtraction means we're going to be using the quotient property. So we're going to divide those two. So I get natural log of x divided by x plus 6 is equal to 7. Okay. So now these x's are still kind of trapped in here. And so maybe if we change it to exponential form, then that's going to help. So that natural log, I'm going to write it as log e of all of this, right? So the base is e. The log is equal to the exponent. So that makes the 7 the exponent of all of this stuff. So I'm trying to solve for x. So I'm going to multiply both sides by x plus 6. And so here we end up with, so we multiply x plus 6 and x plus 6. So this cancels, right? Or becomes 1. So we get x equals to that stuff there. You'll see it on the next slide. So again, e to the 7th times x plus 6 is equal to x. And in order, like this x, man, it just keeps getting trapped in there. So we need to make it free. So we can do that by distributing e to the 7th in here to the parentheses. So we're going to have e to the 7th times x and e to the 7th times 6. Okay, so we get e to the 7x plus e to the 7 times 6. And in order to solve for x, we need to have all the x's on one side. And so we're going to isolate them to one side. So I'm going to subtract the x. Well, let me see if I brought it the other way. So yeah, I took this x over here, and then I took this e to the 7 times 6 to the right side. But notice now that I have my x's are here together. And so what I can do is factor out an x on the left side. So this should say left side. And if I do that, then I'm going to take this x out. So I have e to the 7th. And if I take this x out, I have a negative 1. Okay. So now, finally, after all that, the x is I can actually divide by this so that x is by itself. So we're going to divide by e to the 7th on both sides. And so I end up with x is equal to negative e to the 7, 6, divided by e to the 7 minus 1. And here, notice that I put a lot of parentheses. So if you're not sure where to put parentheses, then do it one at a time. Negative e to the 7, and then you can press enter, and then times 6, and then enter, and then divide it by e to the 7th minus 1. Put that in parentheses. Or you can add your parentheses here, because some calculators are really tricky. If you don't have parentheses, it might give you the wrong answer. Okay, so here this approximates to negative 6.005. So anytime that you are looking at a solution for natural logs or logarithms, there's one important thing that we have to do at the end. And that's always check to see if this is actually a true solution. And the way we do that is you look at your original problem and you substitute for your x the value that we got. So x is equal to negative 6.005. So if I put in for x negative 6.005, right away, if you get let me get my pen out, a negative in here. And notice here, if we add these, it's going to be negative. Then that's going to make it no solution. So we would enter our answer as no solution because the natural log of a negative number is doesn't exist. So you get no solution. I think the next one, let's see what that one would be. So here I have a bunch of natural logs everywhere. My goal is to have one because then I can change it to exponential form. Or if I have two, one on each side with the same base, I can apply the 1-to-1 property. And so we can start combining some of these. So natural log of x minus 6 minus natural log of x plus 6. I can combine those using the quotient rule. So I'm going to divide x minus 6 and x plus 6. And now can I use the 1-to-1 property? And how do I know that I can or cannot use the 1-to-1 property? I can, and the reason is they both have the same base, right? The base is the same. Good job. So I can rewrite this as x plus 9 is equal to x minus 6 divided by x plus 6. And let me see, Daniel says, what happens if something like this? So if you have something like this, you would divide by 6 first. Let me finish this example and then I'll actually work that one out for you. So let's multiply x plus 6 on both sides. So if I multiply x plus 6 here, that cancels, so I get x minus 6. And then on this side, I get these two factors. Let's multiply them out. So x times x is x squared, x times 6, 6x, 9 times x, 9x, 9 times 6, 54. Since this is quadratic, you want to put everything on the same side. So I added 9x and 6x. I'm going to subtract x and minus 6 on this side. So now I have x squared plus 15x minus x plus 54 plus 6. And I'm left with this. Okay. So you want to ask yourself, can I factor this? It's not factorable, so I'm going to have to use the quadratic equation. The quadratic formula. So I wrote it here. But if we enter all the values here, my b is 14, and then my a is 1, and c is 60. Notice what happens. Okay, so let me just come here. We get a negative 44. So since we have a negative in the square root, then that's going to be an imaginary solution. So we say that there's no solution. Okay, so no solution. So let me just, any questions on letter B? Okay, let me go over here. And I'm going to answer Daniel's question really quick. And if you want to, you can see what I'm doing, or you can try to do this one here. But let me just address the question that Daniel had first. And he said, what happens if we have 6 log of x minus 2 equal to 13? So anytime you're trying to solve for x, if you notice it's trapped in there. So in order to do anything, this logarithm should be by itself. So the first thing you want to do is divide by 6 on both sides. So we get log of x minus 2 is equal to 13 over 6. Okay, but the x is still trapped in there. So then now you can change to exponential form because you only have one log. So what is the base for this log that we have here? 10. Okay, so we're gonna write our base 10, and then the log is equal to the exponent, so that's gonna be 13 divided by 6 is equal to x minus 2. And then I'll let Ruben figure out what 10 raised to the power of 13 divided by 6 is. And then we're gonna add the 2 on both sides, right? Yeah, so good point, John. If you don't have a base, like I don't see a number, I don't have a little number here, then it's automatically 10. So Ruben gave me, is that with the +2, Ruben, or is that just the 10 to the 13 over 6?
That's just 10 to 13 over 6.
Or 16, right? Or
No,
6,
it's supposed to be
actually.
6.
Yeah, 6. Okay.
So
So
add
if you
2 to
add
that,
2,
148.
so you get 148. And then if we check that answer, because we always have to check it, right? Well, if you put a 148 in here, minus 2, is this going to be positive? And it's positive, right? Log. And I'm saying like 148.77, whatever. So now you get 146 point something, something, something. But the important thing is that this number is positive, and so that means that this is a solution. So this would be a solution. If you got a negative in here, then you would say no solution. Okay, so I'm almost done here. Let's see. Oops, let me go back. So we have 2 logs. We want to condense to have 1 log or have the same log on both sides. And I don't know why, but I guess I picked a lot of the quotient one here. So these are being subtracted. So we're going to combine by dividing. And then we have a half. So now we change to exponential form. So my base is 9. And the log is always equal to the exponent. That means the half is the exponent. X divided by x minus 8. Some of you might leave this here. You might put that in your calculator. But if you don't have your calculator or something, the half is just a square root, right? So I can write that as a square root. Square root of 9 is equal to x divided by x minus 8. The square root of 9 comes out as plus or minus 3. And we need to solve for x. So I'm going to multiply x minus 8 on both sides. Okay, so, and actually I guess first I separated the positive 3 and the negative 3. So if I multiply by x minus 8 on both sides, then I get x is equal to 3 times x minus 8. And let me just write it here because I want to make sure you know where I'm getting that from. So I multiplied x minus 8 here and x minus 8 here. So this becomes 1. That's my x. That's my x here. And then 3 times x minus 8. So distribute the 3. We get 3x minus 24 equals to 8. So we're going to end up with x equals 12. And on this side, we end up with x equals 6. But we don't want to stop there. You need to check your solutions. So if x is equal to 12, if I put 12 here, this is positive. So that's okay. And 12 minus 8 is a 4. And 4 is positive, so we're good. That means x equals 12 is a solution. But now look at the 6. If I plug in a 6 here, I'm okay. But if I plug in the 6 here, 6 minus 8 gives me a negative 2. Since I ended up with a negative here, then that means that this x equals 6 is not a solution. So this is not a solution, and this one is a solution. Okay. So yes, only x equals 12. Now, next week, we're supposed to review for exam 3, but I was realizing earlier today that for most of in our calendar, exam 3 is due either this weekend or like on Monday of next week. Ruben, when do you have your exam 3 due?
Actually, my students have it today and this weekend. So
Okay, yeah. So I think my class has it due on Monday. So what I was thinking is, since the last 2 sessions have been on chapter 3, it's kind of like all of them together as a review. I did promise my class a video on the review, and so I can just send that to you. I was supposed to give it to them yesterday and I didn't, but I'm hoping to have it done today before the day is over. And I can send that to all of you if you would like to have that. But what I was going to suggest is for next week's happy hour, since we're going to already be in chapter 7, that we would just cover chapter 7, because if we review, we're kind of like going to review for something that you're not doing at that time. So for next week, I would rather move everything up 1 week. We would do the systems of equation. And then what that means is that at the end, we'll actually have 1 week where we can just review for the final exam, for example. So it kind of opens up that opportunity. Any questions? Oh, let me put the survey link up here. I don't know if anybody has put it up yet, but let me go ahead and put it up for you. Let me see. I'm trying to get to it.
Mr. Benny just posted the survey on the chat.
Oh, she did was it for the Google?
No, it's part of the tiny URL survey.
Okay, yeah, this one is for them to get credit for their teachers.
Oh, he also posted that one too. I'm sorry. The forms.
Oh, he did?
Google's,
Okay.
yes. Number
Okay.
1. Oh, it's on there too.
Okay, well, it's there now again. So, I see it. Yeah. Yeah. So either way, it's gonna work, that one or that one. Any questions that you might have? I know we have about 3 minutes, so if you have any questions, please let us know. Or if you would like to get more help, then we have our tutors as well. Yeah, so I think the actual correct link was the one that you guys put in there.
Wow, so everything is great. No questions. Excellent.
Yeah,
Thank you.
I think the last survey link I put is
Mhm.
not working, so I think go ahead and use the one that was sent previously.
The
One
one ending in
and the
one
B8.
in the B8 that said you'll post it. Okay.
Yeah.
Put that one up there.
Okay, everyone, if there's no more questions, I'll be stopping the recording now. Thank you, Ms. Chuka. Thank you, Mr. Carrizales, for the presentation.
You're